Hello, sir. Am I audible?
Yeah, you are audible.
Okay, let's get this started then. Welcome to Starminar podcast by Dhruva Astronomy Club, where today we're going to learn about machine learning for astronomical quantification. I am Khatib Ahmed, and with me today is
I'm Kasturi Apte, and today we'll be talking about physics informed machine learning for astronomical quantification with our special guest, Anurag Datta, sir. So let's get started.
today on the
So,
show. We're
thank.
very excited. Yeah, sir. Yeah, you can go ahead.
So, first of all, thanks for inviting me. And like, I have seen various podcasts in your YouTube channel. They are quite a good initiative by your group. I think you should keep it with it going. And yeah, you can continue your questions.
We are very privileged to
Well,
have you here, sir. Thank you again for joining the podcast.
Mhm.
so, sir, I wanted to ask, what is your field of research? What brought you to it? What is the most fascinating thing about your field of research?
Okay, so actually, currently I am in my bachelor's. So if you see this research in bachelor's is quite a new thing. In the United States or in some foreign abroad countries like the
Hmm.
abroad means US or United States I'm talking about. In those countries, you can find like undergraduate research is a kind of a part of their course curriculum, right? If you find
Yeah.
like they have a dedicated nearly one semester for this research and all, but in
Hmm.
India this particular undergraduate research and all, it's little bit, I just say that it's lagging behind, but okay. So I got this like idea of pursuing my undergraduate research from some of my professors in my college. Actually, when I joined my college at that time, it was a COVID time. Actually, I was a 2020
Of
pass out,
course.
like plus 12.
Hmm.
So, at that time, the problem was everything was in online mode. We weren't available, the college, we weren't like able to visit our college in offline mode and all. So, at that time, it's very obvious that we got a lot of time to explore various domains. So at that time, I started looking into this fields which I can just contribute to. Maybe I at some point I did various competitive codings and all, this stuff.
Yeah.
Uh, when I joined my sophomore year, that professor is my mathematics is of mathematics department. So he told me that you can start doing some research if you want. So at that time, he told me that okay, by this methods you can start working on any project, and then if it is a novel work, then you can definitely publish it in some good journals. Right? So at first, I started my research. My first research paper was on statistics. So there is one law called Benford's law, which you guys must have heard of that. There have been numerous Netflix series on that. So Benford's law have been used for like data validation. So basic thing is that if you are having a data and you apply Benford's law to it, you can identify whether there's been some modification in the data or some kind of this data. What should I say? This morphing have been there, so this kind of thing. So using this Benford's law, at first I started to validate the US 2020 election data set. So later on I found out that okay, this research entire thing, for getting it published in a good journal, you need to have some novel work from novel contribution from your side. So at that time, me along with one of my colleague, like he is also an undergraduate, so both of us started working on that particular thing, and we developed a new novel approach and got it published. So that was my first research paper, and definitely it was not published in some very good journal, but okay, you can say it's like a decent journals.
was a start.
And
Yeah.
yeah, so it's like, this kind of journals, this UGC care list and all. So at that time I thought, okay, I can dig deep into it. Then when I came into the fourth semester, like each year in India is consisting of two semesters, right? So this thing, when I was talking about this statistics paper, so that was actually in my third semester. So when I reached my fourth semester, I started working on this algorithm. So my field was basically, I was much interested into finding out the computational complexities of different algorithms. And this field, I must tell you that this field is quite interesting. Even now, also at this point of time, I also am working on those kind of algorithms and all. So this is something new. And when I came in my fifth semester, like it was the third year, at that time I started working on this research in this field of machine learning. So my first research internship was in this NIAS, it's the National Institute of Advanced Studies. It's a branch of IISc Bangalore. So there I met Dr. Nitin Nagraj. So he is an associate professor over there. So here actually I started working on neurochaos learning, which is basically, this neural networks and all. But the
Yeah.
basis behind this neural network is guided by the what should I say, like the, the pattern in which we humans, like the human brains, learn in a similar pattern. This neural network is learning the thing, and this basically represents the chaoticity. This chaoticity, like if you see in our brain, here are some information which we tend to like remember for a longer period of time. Like for example, if I am telling you something and I am attaching some visuals to it, okay, so
Yeah.
you can see that you can retain those things in your mind for a longer duration of time. On the other hand, if I am giving a long text to you and I'm just telling you to just remember this, so it will be very much difficult, right? So this kind of patterns are followed by the human brain. So that neural network that I am talking about is known as chaos net. So I started working on that and using that chaos net. So the previous works that was done in this chaos net was like it was used to predict this normal things, like this KD Cup 99 data set. There is one KD Cup 99 data set. So it is actually used for classification tasks. So I like previous works that were done using this chaos net was in this basic classification and all. I thought of one thing, like if it can um, understand the chaoticity, like the non-linearity that is present in the nature. So if it can understand that, then we can probably use it for some better purpose. So at that time, I told my professor, this guide Nitin Nagraj sir, so that can we apply it to some real world scenario? Real world scenario means which is going to help the mankind. So at that time, he told me, okay, you can do that. So we started working on something called the spectral characterization data set. But basically, the stars that are present in our universe, they can be categorized into some six categories, like class A, class B, like this. So
Yeah.
first, I tried to classify these stars on the basis of their spectral. Different parameters are there actually. So I started working on that, and we prepared that paper, and now that paper is submitted in one single journal for consideration of publication. Still now it is not published. So let's see. So this was my story about this NIS internship. Actually, this internship was a long internship. Like I worked for nearly 1 year, 2 to 3 months for behind this. And when I was in my fifth semester, I got one, this LinkedIn post popped up. So
Yeah.
here I saw one professor from Triple IT's Free City. His name is Dr. Arun PV. So I saw LinkedIn post for him that we are taking up some interns to work on an ISRO project. So I thought, okay, this is a good opportunity. So if I can contribute to it, so
Mm.
definitely it's going to be a big deal. So just it was very much clear from my side that it is very much big deal to get an intern at ISRO. So just okay,
Yes.
so let's try, just try. So I just gave my application over there, and luckily, I should say luckily, so around August I got the first result, the first you should say the first round result. So that was, I think, based on CV. I'm not quite sure about what was their exact parameter. So that was probably on CV and all. So I got shortlisted in the first round. The second round shortlist was going to happen on the basis of some tests. So they gave the test syllabus and all these things. So they gave us around 2 months to prepare, and there I started like preparing for all those. And the the test was in actually two parts. The first part was this MCQ test, and the second was this interview. The MCQ test went pretty well. Like, I must say, it's not very good, but it went pretty decent. But the interview went pretty well. Like, there were four professors and some scientists from ISRO. So there I got a lot of questions, and I supposedly answered them right. And in the next week, I got the mail from them that okay, you are shortlisted for this internship, and you will be working on the project. And the project was actually denoising of spectral data from the Chandrayaan 1 and 2 data. So that I was selected. So after that, the internship was about to start from June 20th for me, and it is actually going right now. I am working on it now. I had nearly 6 months to work. Like, it was February when I got the selection mail. Nearly 6 months was there. So I thought of trying some other internship. So at that time, I applied for an intern position at Sorbonne University, France, Paris actually. So actually, the Sorbonne University is having two branches. One is in Paris and the other one is in Abu Dhabi. So I luckily got one professor, Dr. Tanuji Chakraborty. He is from Sorbonne University, Abu Dhabi. So there I got selected and started working with him. There I explored the field of physics informed machine learning. As Kasturi said in the very beginning, that I have my
Mm.
skills in. So physics informed machine learning, I started working on that, and we together built one new physics informed machine learning, actually physics informed neural network, which can um, which can undertake some time series data and can try to predict some futuristic data, some futuristic events on the basis of that. Now this physics informed neural network have a bright future. Like, why I'm saying this physics informed neural networks can be utilized in epidemics, then in the field of earth science. You can also implement in it astrophysics. So actually, the domain in which we were working was an intersection of all of this. But later on, I individually also started working on this physics informed neural network for astrophysics. So the main thing behind my project is actually I am trying to predict the sunspots. The sunspots. So
Sunspots.
suppose you
Yeah.
are exactly. So if you are having some historical data about the number of sunspots that is there for maybe 30 days, or maybe some even a year. Okay. So if you're having that, you can make a prediction of maybe 10 days ahead or maybe 30 days ahead. So that I am working on, and I must tell you that this time series forecasting using this physics informed neural network is pretty good. Like, if you implement this LSTM and all this normal traditional methods of time series forecasting, you are getting maybe an accuracy of 80% at max if you're having very
Mm.
good data.
Mm.
But if you are making use of physics informed neural network, then definitely you will be getting an accuracy of around 90%. It's very much possible.
It's a huge leap, right, from 80 to 90.
Exactly, exactly. It's a very high jump. So this all, and also in between, I worked on some like this chaosnet. I have told you, right? So this
Yeah,
chaosnet can also be applied in some other fields, like this Ethereum
yeah,
pricing. If you're
crypto.
having any, exactly, crypto. So there also I tried to apply this chaosnet, and that paper got published. And in that work, I collaborated with one professor from National University of Malaysia. So it was actually a funded work, and the entire funding. Now, see, I got this paper published in MDPI, and if you look this MDPI, the cost of publication in MDPI is pretty high. So at like in undergraduate, you won't have so much of funding to get it published. Like the cost of
Yeah.
publication is nearly 1.5 lakhs. It's a pretty huge amount. So the entire funding was borne by them. And in mid, I also worked on this Silicon Valley scenario. Guys know, maybe Silicon Valley
Silicon Valley Bank. Yeah,
bankrupt. Yeah, yeah, Silicon Valley
yeah,
bankruptcy. So there I told you, at the very beginning, I was working on Benford's law, right?
yes.
So the very first paper which I prepared was a new approach through which I can predict whether there is some fraudulency being going on behind. So I tried to implement that particular, I should say this, that particular approach to predict whether there was some kind of fraudulency behind the Silicon Valley Bank
Valley Bank.
collapse.
Yeah.
Exactly. So that paper that was a funded work, and that was completely funded by Resro University, Poland. So that's a little bit of a thing that I did.
Yeah. So, sir, how did you, how did you go into astronomy? You were analyzing data
Hmm.
about Benford's law, right? Then you decided, was it chance that brought you into it? You said, luckily you got into ISRO.
Exactly. It's not like, luckily, this
No, I mean,
ISRO
of
is a
course, there's
very,
hard work
very,
involved.
very, no, no, this ISRO is a very big organization. Getting
Mm,
into it is a dream for all of the Indians. It's very
yeah,
clear.
of course.
But, this astronomy, like I had my interest in this astronomy from the very beginning, like from childhood. So if I tell you some incident of maybe 3 years back, when I was in my class 12. So at that time, if that was the COVID time actually. So our class 12 board exam was over by, I guess, March, and the last exam was computer science, but it was cancelled. The exam was cancelled because of COVID outbreak. So from that time, the joint entrance examination was postponed again and again. If you remember, at
Mm,
that time, it was a
yeah.
very terrific scenario. Like every day we wake up and see the news, and okay, so this much people have died, and this is a very bad scenario. And
Mm,
every day the education minister is coming in the Twitter and television, and they are telling that, okay, this J mains is postponed, J advance will be postponed, like this. So it was a very terrific scenario. So finally, the J mains was there in, I guess, the month of August. August, if I am not wrong, it was in the month of August, and the J advanced was in the month of September. So if I tell you, at that time there were two J attempts. So my first J attempt was in January, and you guys will be shocked to know my first J attempt score. It was 48 percentile, 48.
40.
48, 48. And the
Yeah.
second
Mm,
JMN's attempt percentile was 97 percentile, 96.7 to 97 percentile. So at that time, it was a very terrific scenario. So I got chance for going for J advance. So I wrote the exam, and there I got a rank of 4824, all India rank of 4824.
four,
Now 4824, yeah. So I tried, like numerous IITs, but I didn't get any of the core branch. Like what I'm telling about this CS and CSEC and this kind of branch, I
Hmm.
won't be getting in IIT. So numerous like many of my friends and family members just told me that okay, if you are into this engineering field, then it's better to do your engineering BTech in maybe computer science or IT branch, right?
Hmm.
So in West Bengal, there is like I am from West Bengal. So in West Bengal, there is one exam called West Bengal Joint Entrance Examination. So
Yeah.
it also intakes student for bachelors. So there I got selected, and I was selected in the IT department, information technology department. So I joined the college, Government College of Engineering and Textile Technology, Shirampur. So here in my college, we have four branches, simply four branches. First is the CS, second is the IT, third is this
IT.
textile technology, yeah, information technology. Third is this
Hmm.
textile technology, and fourth is the APM, apparel management. So at first, I got the opportunity in the IT department. So I did 1 year of my BTech in IIT, and there is an opportunity for stream change. Like if you come in the top three of your of your department, then you get a chance to upgrade your department. I think the same scenario applies for numerous IITs, NITs as well. So I was in the top three of my department. In fact, I was the top in my department, entire college. In fact, so amongst the four department, I got 9.8%, 9.8 CGPA. So I was in the like the top over there, and got upgraded to CS department. So from there, I started working. This started in this CS department. My bachelor started. So at the time of JEE, when I was not able to get admission into the CS departments in IITs, so at that time I thought of pursuing my career in research. But at that point, it was not very much clear that what will I do after my research is done. Like after I do my bachelor's in maybe physics with research, even IISc Bangalore allows those opportunities. Bachelor's in research, bachelor's with research, so it was not very much clear. So I thought of okay, let's try and get into this computer science, and later we can decide. So
Hmm.
after I joined, at that time I was very much confused. In the first year, I must tell you, I was very much confused. What should I actually do? Even at some point, I started my own YouTube channel. So I did really everything. So after it was done, I started focusing, and the professor
Hmm.
about whom I am talking about this Dr. Arnob Kumar De. So
Hmm.
he is a mathematics faculty, HOD of Basic Science Department. So he told me that okay, so if you are here in this college, you should better focus on what you are doing currently, right? So I thought of okay, so he used to take our mathematics classes, and during this lockdown, okay, so at that time, this streaming and all being done, and at that time,
Yeah, yeah.
okay, fine, I am trying to get familiar to what I am doing. At that time, like it's a very confusing situation for me. What should I actually do? Like, so he completely guided me. I should say that this Dr. Arnab Kumar, they completely guided me. What should I do next? So at that time, okay, I got into research, I told you. And this astrophysics, uh, I jumped into this field from from Dr. Niti Nagraj. When I told him about my proposal, that why don't we apply the same in this star, like spectral classification for this purpose. So he told me definitely you should try, and he kind of encouraged me. And from there, I found this astrophysics can be implemented along with computer science, maybe machine learning and artificial intelligence. So yeah, by this I started having my interest in this astrophysics domain.
Astrophysics.
And
Hmm.
yeah, astrophysics.
So,
So yeah,
can you elaborate more on data science driven astronomy?
yeah. Now see, this data science. If we look into data science, it's more about predicting. Like it's more used in economics, like for a good example will be stock price
Stock
prediction,
market.
this stock
Hmm.
market,
Yeah.
exact. So stock price prediction, and also it's used for maybe weather prediction, this
Hmm.
common applications. But you won't find much application of this data science in astrophysics. So it it is kind of coincidence that I started working on this in astrophysics, and I found much interest in it. And this this intersection of machine learning or data science along with this astrophysics is having a bright future ahead. And if you get your interest in this, you can definitely get much more out of this. This field is definitely new, and if you see most of the astrophysicists, they do just like pure mathematics or pure physics, this pure physics
Hmm.
paper. If you notice this big journals, so there you can find like strong astrophysics paper, which won't be possible for a student who is undertaking his bachelor's in computer science. So better, if you are in this undergraduate, maybe doing your bachelor's in computer science or information technology, you
Hmm.
try to play around with the data that is available. If you notice, ISRO along with NASA, all of them are having their own libraries where they have their data. So there you can move around with the data and play around with it. Definitely you can find some good outcome from it.
That's what I wanted to ask, sir. Where did you get this data? You had after joining ISRO, you got this data, right? It's not
Yeah.
available in the public domain.
No, actually, ISRO data is available in the public domain.
Available in the public domain.
Yeah, recently when Chandrayaan 3 was about to launch, this
Hmm.
Chandrayaan 3 is launching, like the landing site. Actually, there are two landing site here right now. There are two landing site. One is the primary, and the another one is alternate landing site. So there is one website called pradhan.issc. So from there you can find this Chandrayaan 1 as Chandrayaan 2 as well as Chandrayaan 1 data. And during the time of this Chandrayaan 3 liftoff, before maybe 1 or 2 weeks before, they made this data completely open. And
Public.
even before
Hmm.
that, it was there. Like if you notice, NASA's Jet Propulsion Laboratory have the data of Chandrayaan 1 M3 data. M3 is actually moon mineralogy mapper. It's a spectrometer kind. Okay. So
Hmm.
you can find this data anywhere. Like if you even if you go to Kaggle, I am not sure, maybe you can find it over there as well. But most of the data that is available in the NASA's website, it is there in Kaggle. Like I have worked on the Mars data. So there was one MRO mission by NASA. So I found the data completely from Kaggle. So later on, I to check the like provenance of that data, whether this data is valid data or some guy have put it. So I just checked it, but it was there in the NASA website. And it was as it is. So this data is available in the internet openly. And also I have worked on one thing like star versus galaxy classification. And there is one Aries is a institution, is there in Nainital. From there I got like nearly 400 samples of data. And that data was having, it is a tagged data, tagged image file format. So there it was written whether it's a galaxy data or it's a star data. And if
Hmm.
you apply some good modeling behind it, good machine learning modeling behind it, you could get a better outcome. So there I made use of simple convolutional neural network, and I got a very good outcome. So the outcome, the percentage, if I am not wrong, it was 95% accuracy. No, that's a very huge amount, huge number.
Yeah.
Also, one of my research paper in which I worked about hazardousness of asteroid. So here also I made use of chaosnet. Okay. So chaosnet, using chaosnet, I tried to predict the hazardousness of data, like asteroids. The data was available publicly on NASA's website, and
Hmm.
there it could predict. whether your asteroid that is coming towards Earth, is it hazardous or not. So if you make use of this convolutional, this just normal methods, so maybe this SVM, random forest, all these normal methods, there you can find the accuracy will be nearly 50%, 60%. It's stopping near that. But using this chaos net, we got an accuracy of nearly 70%. And I think it's the highest accuracy still now. So this all things can you can do in this field of in the intersection of computer science and astrophysics. The data is available everywhere. You just have to get some motivation behind it and start working on that. You will get it done.
So, like, out of curiosity, how distant galaxies, or like, tell what amount of distance can we observe these things or predict about them?
The distance, it was around 180 astronomical unit. 180
Okay.
astronomical unit. So it was there in the data set as well. So
Mhm.
yeah, this is
And generally, like, what programming languages do you prefer for your research? Like for
okay.
ML or DS?
Mhm. For research, the only programming language that is going on in today's world is Python. Along with that, some professors who are good in statistics and all this, ISI professors, if you notice, Indian Statistical Institute, they are much into this R language, R. So
Mhm.
for research purpose, Python, like if you are doing your research in the very beginning stage, Python language you should prefer, because Python, this is very handy language. You can start working with it
Yeah.
very easily, and there are various packages. Like if you notice Matplotlib, you can draw
Matplot.
very, very, very colorful graphs using this.
Yeah.
That you can't also do. That you can't do if you try to draw the same thing that's using C or C plus plus. Will it be possible? Right. So yeah,
So,
Python.
because that's the
Hmm,
thing, sir, we're also engineering students in our first year, as are many of the others watching this right now live. So that's why we
hmm.
wanted to ask if we had an interest in this field. So how do we start up? How do we go about it?
Okay, okay. So at first you should make a problem statement clear in your mind, that okay, I want to work on this particular problem statement. Okay, now you try to read some papers that are in that domain, whether there are some papers or not. Like sometimes if your idea is really a genuine and new idea, you won't find any research in that field. So at that time it's recommended to start working on that. Okay, you will definitely get it published as a new idea. But if it is you're finding like nearly 20 or 30 articles are there in this particular direction, then it's recommended to start reading those articles at first. And for reading at first, you should try to read out the abstract, then you should move on to the conclusion. Okay, so
Hmm.
it's a not quite conventional way, but I followed the same thing. At first I read the abstract and then the conclusion. So by this, the abstract gives a very clear idea of the problem statement. Most of the research papers have the problem statement written in the abstract, and conclusion gives an idea of the results that you are getting. Now when the problem statement and the outcomes are clear to you, then it's very obvious that you can understand the mechanism behind it, right? So there you can have a clear edge on that idea, and using that you just try to explore 20, 30 articles that are there. And after that you have a very clear idea in your mind that okay, this works have been done, this works are remaining. So if the idea that you have thought it's there in the remaining part, then definitely start working on that. Otherwise you try to think some novel idea on that. And one more thing, for research, mathematics is a mandatory thing. Like if even if you notice this astrophysics and all, there also you will need a lot of mathematics. Okay. Now the modeling thing, physics informed neural network, as I was telling, physics informed neural network, it is actually if I tell you the mechanism behind it, so physics informed neural network, the basis behind it is a general neural network, simple, a neural network. But the thing happens in a two-phase step. The first phase is the pre-training phase, and the second is the training phase. Like if you notice a normal neural network, it undergoes the training phase, like
mm,
backpropagation. Must have heard of that, backpropagation and all. So it's a like training phase which is going behind it. But for physics informed neural network, you have a pre-training phase attached with it. And in the pre-training phase, the neurons that you are having, they try to learn from the dynamics of some physical system. By physical system, what do I mean? Have you guys heard of Lorentz system? Lorentz set of differentials.
Mhm.
So it's actually uh, it models the weather the models, the weather patterns, and everything. So
mm,
there is something called the butterfly effect. So if you notice the Lorentz curve, it symbolizes a butterfly. Okay, so the curve,
mm,
it's a 3D curve. It symbolizes the butterfly. So suppose taking the example of Lorentz system, one very good research problem I am telling you. So you can also probably work on this. So this Lorentz system have been used for edges to mathematically model the climatic scenarios. Okay, so the climate patterns and all.
mm,
So if you climate patterns, yeah. So if if you can try to predict maybe rainfall or precipitate, like this wind speed, okay, so you can do that. Now how can you do that? So as I told you, this pre-training phase, in the pre-training phase, the neurons that you are having will be trained by the dynamics of this Lorentz system. Now training this neurons will be based on uh, what we call this mathematical thing behind is, it's very tough to explain, but it is actually the first derivative, second derivative by this, it is having a loss function, and using that it tries to train the neurons in the pre-training phase. And now you have a set of weight and biases in the pre-trained neurons. That set of weight and biases, you can use the method called transfer learning, and you can transfer that set of weight and biases to a new scenario. And in that particular scenario, the input will be from the real world scenario. Okay, at first we were training the neurons using the dynamics of the chaotic system, here by the Lorentz
mm.
system. And now in the training phase, we will be training it by making use of the real time data. Okay, so using the real time data, you can maybe suppose you are having an historical data of maybe 30 years. You just try to break it down by the 80/20 rule and try to model the neurons, okay, the neuronal patterns.
Mm,
And based on that, you can probably predict what will be the, suppose you are having the data set of wind speed. So you can predict the wind speed of coming 30 days using this physics informed neural network. And that you can do by a very better accuracy than the
accuracy, yeah,
normal
like you
LS.
said, it has a higher accuracy. Yeah.
Very much higher accuracy. So you can try this stuff. It's a good problem statement, and I don't think that there have been enough work in this field of this physics
Mm,
informed neural network, because the first paper that came out, it was actually called physics informed machine learning, and it was published in Nature, Nature journal. So there it was published, and it was published in the year, I guess, 2018. And this
mm,
physics informed neural network came into existence much effectively during the COVID time. And there were
mm.
numerous neural networks, physics informed neural network, that kind of predicted the COVID trend quite quite accurately. So thereby it came into existence, like people started noticing that, okay, this physics informed neural network is having a good edge over the other. Like if you notice ARIMA and all this LSTM and all statistical methods, There is also one method called status smoothing, SES. Okay, exponential smoothing. So thereby, this physics informed neural network performed pretty well than those. So from that, people started noticing that okay, we can probably use this physics informed neural network, and it started growing. Okay.
Sir, I wanted to ask, what are your hobbies? What do you do for fun or to, distress from work or otherwise in your personal
Okay.
life? And
So so chess, simple.
you play chess?
Yeah, lot, a
Achha.
lot.
So like professionally or just like a
No, no,
time,
no, no. Just
like
amateur,
for fun?
just simple amateur for fun.
I also used to play chess, but I was not that good at it.
No, even I am not so good at it. I am having. I think last time I played, I was having a rating around 1400 in chess.com. So it's a very pretty decent, Not so good, not so bad.
So, sir, what would you say? What are the different approaches to predictive modeling in astronomy?
Oh, okay. So different approaches. If you're working with imagery data, right? So if you're working with
Mm,
imagery data, like I worked some of the imagery data I worked on was this Aries data by Nainital Observatory. Then
mm,
I worked on the Mars data. Okay, so I just want to add one more thing about this Mars paper. It will be much more interesting for the podcast as well. uh, this Mars data actually, it had the tagging based on sand dunes. Okay, so
mm,
the MRO images that was given by NASA, it was tagged that whether this particular patch of image that you are observing currently, whether it's having sand dunes in it or not. So my
mm,
proposition using that was I made use of one uh, like model. That model was actually convolutional neural network was there, but it was a hybrid kind of model. Thereby we made use of convolutional neural network, unet and unet plus plus in parallel actually. So it's a complex network. So using that, I tried to predict whether there is sand dunes on a surface or not. So this data is there,
mm,
and you try to train the neurons based on whether this particular image you are getting, and you try to predict whether this patch of land is having sand dunes or not. So you just understand, if we can predict sand dunes on the Martian surface, okay, so suppose a rover is there, suppose the Curiosity rover, you must have heard of that, on the Martian surface. So
yes.
suppose the
Mm,
Curiosity rover is there, and you can predict that the Curiosity rover is moving in this particular domain, and in maybe coming 5 hours, 5 hours in Mars time. Okay, so in coming 5 hours, uh, the region in which Curiosity rover is moving, will might be having sand dunes in it. So if you can predict it, you can potentially save your rover from getting covered with dust or sand
and,
actually.
mm,
So the problem with getting covered with sand is actually the solar panels in the Curiosity rover. So if it is getting covered with dust, the solar power that they can generate will be pretty less in comparison to what it
mm,
used to do previously. So thereby you can understand, like, if you can predict this particular region is supposed to have some sand dunes in the coming 5 hours, you can probably move Curiosity to some other place. So
mm.
this is one thing I wanted to mention. And can you please repeat your question that you told about? I can't remember. Probably
So I
you
was
asked me.
asking about different approaches to predictive modeling.
Okay, okay, fine. So as I mentioned, if you're working with imagery data, you
Mm,
can make use of convolutional neural network, the very basic. Next, you can make use of unet plus plus, and some other advanced modeling you can use. The most important thing that you can use for this astronomical thing is you can try to build a hybrid model. And by hybrid, I mean to say, uh, suppose uh, okay, let me think of an example. Suppose you have three gods, okay, three gods you are having, and one god is having the power of education, second god is having the power of money, the third god is having the power of
mm,
strength. You try to take the best thing from each of them and try to make a new deity for you. No. So by
mm.
hybrid modeling, I meant to say
Hybrid.
that suppose
Yeah.
exactly. So you try to take the best that you can take from convolution neural network. You try to
Mm,
take the best you can take from UNet and from UNet plus plus, and you try to prepare a hybrid model which can work well with this imagery data. So this is gone for imagery data. And if you're having this normal statistical data, like simple data, this normal data, this text form. So in
mm,
that case, you can probably make use of this chaos net is a good option because chaos net can model nearly many things in this nature. Then you can also probably work on ensemble methods, which is also an hybrid kind of thing. Okay, and probably you can make use of some neural networks. Okay, this all things you can do if you're working with this uh,
mm,
statistical data. Otherwise, if you're working with imagery data, as I told you, and
mm,
talking about this normal statistical data, you know, you won't find much research gap in that, because most of the gaps that was done, that was there, was covered actually. If you notice in IEEE, uh, in most of the IEEE conferences that happen these days, you can find nearly, suppose an IEEE conference is taking 50 papers, okay, you would find
mm,
nearly 25 papers on the statistical modeling or statistical data, and that is done using this neural networks and all. So
mm,
try to pick up some new data, okay, try to pick up some new data and
mm.
try working on that, because this
Okay, sir.
data set is very much new. Mhm.
So here's a fun question. Like, what kind of movies or series would you like to suggest our audience for them to like develop interest in astronomy or fields like that?
Okay, okay, movies. I can't remember the last movie I saw. Okay,
Yeah.
I think in 2022 I watched a series. It's called Rocket Boys. You guys must have heard of that. So that's a very good series.
Yeah.
Uh,
Rocket
I
boy.
have
Yeah.
heard I have heard that there is a season 2 out, but it's a very hectic
Mm,
schedule for me. I can't even find time to.
mm,
Very bad.
So then, what message would you like to finally convey to our audience, like in brief,
Okay,
maybe?
okay, okay. So whenever you are joining college, like for bachelor's for the very first time,
mm,
you try to explore the much you can. You try to do whatever you like whatever, you know. Try to explore. Even for me, I explored. I told you competitive programming. I did, and those things that you are exploring and you are spending time on today, you will definitely find some output from that. Maybe you are not finding output from that today, but you will definitely
mm,
find output from that in a future point in time, definitely. Like one simple instance I want to tell you, this comparative programming I did for nearly 6 months, yeah, nearly 6 months. And
mm,
comparative programming what happens is, the optimization thing. You have an algorithm, you will have to optimize it as much as you can, and this thing helped me in my research papers on algorithms, right? So you can definitely find some benefit from everything you learn, right? There will be some benefit at least. And coming to your interest and all, try to find those things, like try to choose those things as your career which interests you. Like suppose you
mm,
like working on some research, okay, suppose you like working on research, and you started doing your research and all. and now you are trying to move into this industrial field now, this job and all. So you can't perform well in that scenario. Similarly, in the vice versa, if you are finding much interest into coding and all, like coding, I mean to say that software development and all,
mm,
you can't like give your 100% in research if you are willing. So be very specific about what you are made for. Yeah. So, but I
mm,
think every student, whenever they are coming in their junior year, like I am telling about the third year, so every
mm,
student must have must be getting a little exposure about what they are actually made for. Not everyone
yeah,
is made for not everyone is made for software development and all. Not everyone is made for this full stack and all. So you will have to find those regions in which you are good at. Find one particular region in which you are good at and try to be the master of that. That's it. And try to make you up to a particular level in which you can say that, okay, I am the master of that, no one can beat me in this.
mm.
Try to build you up to
Excellent,
that
excellent
level.
advice. Yeah. So, sir, now we'd like to take an audience question. One
Sure.
second. So, sir, the audience question is, what kind of innovation would you like to bring in this world?
I didn't get you. Can you please
Sir, the
repeat the
audience
question once?
question is that
Hmm.
what kind of innovation would you like to bring in this world?
Okay, in this world, okay, that's a very big question. As of now, I am in a very small age. Even I haven't crossed my 20 years of age. Okay, so innovation to this world, at least my futuristic goal is to uh, try and get things which are not going right, like this education field. If you notice this education domain,
Hmm.
there is a lot of bad things going right now. Like, I should not name it, but this coaching institutes, it's not good.
Yeah.
Okay, simply I am telling,
Yeah.
it's not good at all. They are charging a
Mm,
lot of money which is not worth it. Simply I'm
mm,
telling you, it is not worth it. One simple instance I want to share: my JEE advanced preparation, I did it completely through self study. You can
mm,
find like many one telling that if you are willing to crack JEE advanced, like IIT JEE or
mm.
NEET, you must have some coaching guidance behind you. That's
Yeah.
not true. Actually, it's not true. If you are willing to give you 100%, you will get it up. Definitely will get it up. And even if you are not able to make it up to IITs, for me, I got qualified, but somehow the rank was not good enough to get CS or EC in some good IITs. So
Mm,
let it be. But even if you are not able to qualify IITs, or even if you are not able to get into good NITs or not even government colleges, don't get demotivated. It's not the end actually. Okay, you
mm,
can get it out. Anything you can get out through anything. Like, if you are pursuing your bachelor's from any tier 3 college as well, if you
mm,
notice this foreign universities, I am taking example of maybe Stanford, Harvard and all, they won't
mm,
mention that you need to be from IITs or you need to be from NITs. They don't mention. But if you notice this, this coaching institutes, they mention it
mm,
very clearly that if you are from IITs, then we can make you eligible for teaching our students. Like, there is one
mm,
very big coaching institute who if you move into their job section, and if you try to apply for any position, they have made it very much clear that the applicant should be from a good IIT or NIT.
mm.
This kind of things are not good.
Yeah.
And coming to the innovation part, if I get enough power in my hand, maybe at a later point of time, I will try to fix this education thing right now. Like, the
Mm,
perspective that our world is having right now is very much competitive. Okay, suppose if you notice the students right now in this world, uh, they are competing with their own friends. you know Suppose
yeah.
one guy is
Mm,
having some good internship. For example, suppose one guy got a good internship, the other guy is trying to like get that in any sense, like it's a competitive kind of thing. You can't grow in that competitive attitude. You should, it should be collaborative in nature. You should try to collaborate.
mm,
Okay, so you have got this internship, so what are you getting to learn from here? Just we can also collaborate on that. So that's it.
mm,
So I think the perspective should change definitely. And if at a later point of time, if I am having that opportunity, so actually my future goal is to join as a professor in some institute. So if I get the opportunity to teach students, then I would probably try to reshape the thinking process, because this is not the thing, no, this is not.
yeah. So it is a very noble cause that you mentioned to try to, you
Hmm.
know, fix the
Yeah,
education system
definitely
and the
everyone, like I think
wrongs in that.
everyone should try to refix this education system. Like
Mm,
one small thing also I want to mention. If you notice in the bachelors, student try to apply for gate, gate examination,
mm, Gate,
graduate
yeah.
institutes.
Mm,
So if you notice in gate nowadays also this coaching thing have started.
Coaching. Mm,
Yeah. And wherever there is some coaching thing behind it, the examination is not going to be conducted in a good humor, okay, good sense. It's not going to be
mm,
conducted. Similarly, if you notice the what we call news after the JE examination, you can find in at least one center there have been some news of cheating, some
mm,
question, some guys getting the answers in their screen simply, this kind of things happen. If you are into coaching for a particular examination, that examination is not going to happen in a good manner, definitely not going
mm,
to happen, because guys are spending maybe 1 lakh, 2 lakh, 3 lakh for a coaching thing, okay, for getting the coaching. And
mm,
the coaching industries or the coaching institutes, they will have to get results out, otherwise the students won't enroll in the next batch, okay.
mm,
And it's a business thing, like anyone will try to get the maximum benefit that they can get out of it. So it is not
mm,
going to happen in a good manner. So I think this coaching thing should not happen, and if it is at all happening, then it should be at very minimal cost, like it should be a reasonable cost, no. So this thing I must mention.
mm. Mhm. Yes. So, sir, there is
Okay, sir. So,
another. Yeah.
Hmm. Sure.
audience question. We have another audience question, and it goes like, "Are you interested in startup, or what are the different startup options in the field of astronomy?"
I don't have much knowledge about startups. Even I don't feel that I am qualified enough to start any startup. I don't have much knowledge of it. Okay, simply.
Okay, sir, it has been a fantastic opportunity to have this interaction with you today. And me and Kasturi are beyond grateful for this, as are the audience, I'm sure.
Thanks a lot.
Kasturi?
Yeah, actually, my network is a little bad over here. I didn't hear what you guys said for the last like two
Yeah,
minutes.
yeah, exactly. I thought his her screen was
Mm.
stopped for a second.
Yeah.
I was just telling that it was an fantastic experience talking with sir today.
Yeah, totally. And sadly, sir, we are at the end of this, but this was a really great chat, and we got so much information, and even you, ignited an interest in us. So, thank you again for this podcast.
You're welcome.
So,
Sir,
now
so
we'd
now
like
I
to
think.
call upon our
Hmm,
president for vote of thanks to Sir for such a good podcast.
Okay. Good evening, everyone, along with our Anurag sir. I, Nyaneshwari Pawar, President of Dhruva Astronomy Club of the YPIMR, present here today with immense gratitude in my heart, honored to deliver this vote of thanks on behalf of everyone present in my club. First and foremost, I would like to express my profound thanks to Anurag sir for gracing us with their presence and for sharing their valuable insights and experiences. Your words have inspired and motivated us beyond measure. Your words have will leave a lasting impact on each and every one of us for a long period of time. Your dedication and commitment to your field of expertise have been nothing short of exceptional. Your passion for whatever you do is evident of your interaction, presentation, and initiative you have undertaken. You have learned not only from your knowledge, but also from genuine enthusiasm and exude when discussing your work, like as you did in your podcast today. Furthermore, we extend our gratitude for efforts and resources you have invested in making this podcast. Your support have been invaluable and we are deeply grateful for your opportunities you have provided us. On behalf of everyone here, I extend our sincere appreciation for the inspiration you have instilled in us. You have challenged us to aim higher, to strive for excellence, and to never settle for mediocrity. Your impact goes far beyond today's event. It will resonate in our lives as we move forward in our own endeavors. Like me being from a computer science background, whatever you said, like about languages, about it could be data science, machine learning, and React and R, whatever it be, it resonated me and I really felt okay, I'm talking to a senior that is actually guiding me. uh, we are truly privileged to have the opportunity to learn from you and to be inspired from you. We are really thankful, sir.
Thank you for this brief kind of thanks. So, yeah,
And that is a wrap. Sadly, we're at the end of our episode. Thank you so much, everyone, for listening. We had a great time. I really hope you enjoyed. The main takeaway for me today was that this field that Sir mentioned, machine learning and data science and astronomy, this is a new thing. There's a lot of scope in this, like Sir mentioned, and we're a part of astronomy club, so all of us are really interested in astronomy. Also, we're pursuing our engineering, we're programming. We're definitely going to look into this, and thank you so much, sir, for introducing us to this field.
it's my pleasure.
And like you mentioned, the programming languages Python and R for research, the problem statements, everything. We are beyond grateful for this.
Thank you all.
Thank you, sir.